Why is it impossible to find shortest path if a graph has negative weight cycle? This is an important question. If you have any graph G which has a negative weight cycle, why is it that you will never be able to find shortest path in this graph? Let us take a graph and understand this concept. If this is your graph, something like this, and let us say it is having a negative weight cycle somewhere. I'll name the vertices as A, B, C, D, E and F. What we'll do is, we'll form a cycle somewhere here. Let us say CE, ED and DC. This is a cycle and we'll make the total weight of this cycle negative. This edge be 2, let this be minus 3 and this be minus 1. Which means if you do CEDC, if you do this traversal, 2 plus minus 3 plus minus 1 will give a total of minus 2. So this is a negative weight cycle. Cycle CED. CED is a negative weight cycle. Why is it that if this cycle is present, then in this graph you will not be able to find the shortest path? The reason is, if you are trying to find the shortest path from some point to some point, let us say from A to F, if these are the directions and you want to find from A to F, the problem is while you are trying to find shortest path from A to F, you may go through this cycle. You have this option. You can actually directly go from A to C, C to E, E to F. But if you are going through this cycle, you have an option of getting negative weight. That is, if you traverse through the cycle once, your total weight will decrease. If you traverse through the cycle twice, again the total weight will decrease. So if you keep doing this cycle again and again and again, the total weight, the total path length will keep decreasing and decreasing. If this keeps happening, then how can you find the shortest path? Let us say this path, here it is having minus 2, the total weight of the cycle. This is minus 2. If you go through the cycle once, your total weight is minus 2. If you take the cycle twice, it will become minus 4. Again, if you go through the same cycle, it will become minus 6, minus 8, minus 10 and so on. So, the number of times you take this cycle, your total weight will keep decreasing. So, even if you don't have to take this cycle, let us say you have to go from A to F, you can actually go like this. But what you will do is, if you want to find the shortest path after you reach C, let us say from A you reach C, then you will once take this cycle unnecessarily so that your total path length will decrease by 2. What will you do then? You will again take this cycle unnecessarily so that your path length will again be decreased by minus 2. So you will keep doing this whatever number of times you want, and after that you will proceed to F. And if you again want to shorten the length, what can you do? Take the cycle again 2 more times, which means you can keep doing this again and again and get a smaller and smaller and smaller path. Because of this, it is never possible that you will reach a shortest path in a graph if it has negative weight cycle. You can keep taking this cycle again and again and find an even shorter path. So you will never hit a rock bottom where you can say this is my shortest path. This is the reason because of which it is impossible to find the shortest path if the graph has a negative weight cycle.